Have you ever wondered how a piece of black rock buried 1,000 feet deep within the earth transforms into a powerful magnet in just a few months? Furthermore, why are billions of dollars spent globally each year on these seemingly ordinary-looking chunks of metal? Today, I will take you through the incredible journey of the magnet, often described as the heartbeat of the modern world. This remarkable journey begins deep underground. Rare earth elements and minerals, such as iron, barium, strontium, or neodymium, are sourced from mines. Geologists first scan the area to determine the location and quantity of the ore deposits. Next, specialized drilling machines penetrate successive layers of the earth. Once the necessary data is gathered, controlled explosions are carried out. Unlike standard mining operations, these are not haphazard blasts. The exact amount of explosive and the direction of the rock fracture are calculated down to the millimeter to ensure the quality of the ore remains intact. Afterward, tons of ore are transported to the processing plant via massive, heavy-duty conveyor belts and trucks. Once the rocks arrive at the plant, a complex series of operations begins. First, they are thoroughly washed to remove any surface mud, dust, or impurities. Then, they are sent to a vast grinding section where the process of transforming the rock into a fine powder takes place. The rocks are fed into ball mills or jet mills, which rotate continuously for 4 to 6 hours, grinding the material down until it becomes a powder finer than a human hair. Throughout this stage, the machine's temperature is strictly maintained below 180 degrees Fahrenheit to preserve the magnet's natural magnetic properties. Once grinding is complete, the flotation process begins. Here, special chemicals are mixed with water in a massive tank to create a foam. A fascinating scientific phenomenon occurs at this stage. The valuable mineral particles attach to air bubbles and float to the surface, while rock and sand sink to the bottom. This entire operation takes place inside a completely sealed tank to prevent any harmful gases or dust from escaping. Then, the real magic, the mixing process, begins. Neodymium, iron, and boron are blended in precise proportions. The mixture is then loaded into a vacuum furnace. However, before heating begins, all air is evacuated and replaced with argon gas. This is crucial because even the slightest contact with atmospheric oxygen could ruin the neodymium. Next, the materials are placed in an induction furnace where temperatures reaching approximately 3,000 degrees Fahrenheit melt them into a seething molten liquid resembling lava. In the blink of an eye, the molten material is cooled and transformed into thin flakes or metal chips. Think the process is over? Far from it. These chips are fed into a machine to be pulverized into a fine powder, with particles measuring just a few microns. This powder is then loaded into a steel mold surrounded by a powerful magnetic field, capable of reaching strengths of several Teslas. This causes the powder particles to align in the same direction, much like thousands of compass needles. This brief, few-second process determines the future strength of the magnet. The blocks obtained after pressing are initially fragile, much like unfired clay bricks. To transform them into robust, solid metal, they are fired in a massive oven at temperatures ranging from 2,200 to 2,400 degrees. After being exposed to this heat for several hours, the powder particles fuse together to form a solid metal block. In the next stage of the factory process, these blocks are cut to specific sizes using diamond cutters or laser machines. Finally, we arrive at the most remarkable stage. Despite all the processing, these pieces have not yet become magnets. They remain ordinary chunks of metal with no attractive power. Their true strength is awakened through the magnetization process. They are placed inside a machine, and a high-voltage current, thousands of volts strong, is passed through them for a mere 1 to 5 milliseconds. The magnetic field generated in that instant is approximately 10,000 times stronger than Earth's natural magnetic field. This is how an ordinary piece of metal transforms into one of the world's most powerful magnets. Finally, an automated machine performs a quality check. Great care is taken during packaging to ensure the magnets do not stick to one another. Plastic sheets or special spacers are placed between them. Once packed, these magnets are sent to power the motors of electric vehicles like Tesla's, massive wind turbines, or hospital MRI machines. From underground rock to the cutting-edge technology driving our world, these small metal pieces serve as the invisible power behind modern civilization. That small piece of metal, which appears ordinary to the naked eye, is actually the invisible heart of the world's most powerful technologies. Behind it lies a journey spanning from mines to factories, involving countless steps, precise science, and extraordinary human ingenuity. That's all for today. If you enjoyed this video, please hit the like button and subscribe to the channel. See you in the next episode. Thank you.